Hi everyone. Today we are going to talk about trie data structure. So at a high level, trie means just has a characters as its children like this. This is a like pictorial representation of trie, and let's understand with examples why we need the trie. So suppose we have a two strings. So we have to store those strings computer or disk and any. So what we will do solution, we will create an array. We'll store and here, and we will store and so this will point to this. This will this. So this is a array of a string. In this, you can see there are a couple of characters a n which are repeated into the multiple strings, right? So in this case, we are not reusing the memory. Okay. So what we will do is, suppose if we have reused this memory, first of all, create a then we will just reuse the characters. So yeah, so as you can see, and at last write a d and d. So that's how pictorial representation of a trie the two strings and. So let's understand. Can we insert the triple strings into the trie? So suppose the first string is and, second string is and. So first of all, we will create a row. So every node will be having like a hash table, which will be the key value pair, where key is a character and value node and boolean variable. It will take if this character is end of the word. So that will be the structure of. So suppose we are at a and, we are at a first character. So our current will point and we will check if a is present as a children of. It is not present, so insert a. Okay, then increment to the n. So our current pointer will point and n is not present as a children of a, right? So insert n. So our current pointer will go to the n again, and again we will check d is not present as a children of insert. So that's how we have inserted the and word into the trie. Yeah. So how much time complexity the insert operation will be having? It will be a linear, because we are iterating the string once and we are insert trie. Okay. And let's get to the second word. Our current will point to the root again. Our first word, a is present as a children of, we need to insert. N is present as a children of a, insert. But t is not a present children of a n. In this case, we will add. Okay. So what is this nodes? These nodes is a key value pair where t is a value and node is a value. So you can see we have inserted two words into the trie. So the time complexity for insertion will go of n. So you can see we are reusing the space here. And all the common characters can reuse the space. And whenever we are at the last character, right, we will set the boolean variable which is word end as a true. Same for this d also, is word end equal to true. Okay, so that is the first important operation. We have to insert strings into the trie. So suppose again we have to search. So there is a string am, okay, and we have to search if it is present into the list of strings or not. As we can see, it is not present. So what we will do, our current point, it will check if a is present or not. A is present, m is present or not. M is not present, then it will return false. So that's how it works. Searching also. So searching operation also take a o of n will be the length of string. So the use cases of a trie. So first is have a lot of strings in question or problem. Second is we have to store the strings. Third is have to search for a specific string. If you are getting this kind of vibes question, we have to store a lot of strings and we have to search a couple of strings into that ocean of strings. In this case, we should look up for only trie data structure. Okay, so that's all about definition of a trie. Let's try this.
As we have seen on pen and paper, can we insert the trie? So let's create this for the trie node. Create a constructor and keep the hash table. This hash table will be the key value pair, where key is a children character and the value will be the and another word as a boolean variable. Keep it as create a root node is created. So while inserting the word, take a ref each character, visit character by character word, and if character is not present into that trie, create a one trie node character dot, then create one entry. If it is present already, then just jump on to that dot current dot and at last for current word. So just store the word is come. So just store the boolean variable word is sir. Again same take, then move if a character not in run dot st means the character, then else if it is present character by character go down, and we are at a last starts with also same current to the current character in character not dot. So we have to search the word, right? In this case, so we have to return is word end or not. This case of go down one by one, and we have done this. So that's how we coded for the implementation of this. Is pretty simple and pretty useful whenever we are doing a lot of spin-offs into the coding problem. First thing should come to our mind is predicate. It will make our life easy to store the string, search a string into the solution. That's all from my